Hi everyone. So in this video, I am going to take you through Regression Lab. I will be using Art of Stat app to show you some of the stuff that you can do that should be sufficient to finish your lab. So once you get to Art of Stat app, you go to their web-based apps. This is how the page looks like. Most of you are already familiar with it. And under the heading association, correlation, and regression, that's where we are. You have all these sub apps which you can use to finish your regression lab. If you want to find association between two categorical variables, scatter plots, correlation, explore linear relationship. Uh, you can do all those kind of things using these apps. So I'm going to show you a few things that will come in handy to finish your lab. Click on the first thing we're going to do is we're going to click on explore linear regression. So once you click on that tab, you will see there are two sub tabs: scatter plot and residual plot. Initial relationship, you can draw your own. You can do a random scatter plot, you can do a linear, a quadratic relationship. So we are working with in the linear world, so we're going to stick to that. So this is like how a initial linear relationship would look like. A scatter plot for a linear relationship would look like. Now you can with 50 points. These are just some random points, and then we are fitting scatter plot on x and y. Now you can fit a smooth trend. That's a smooth trend, which also looks like lines. So you're in good shape. If the smooth, let's say, if I fit a quadratic thing, and then I'm fitting a linear line. See, this a smooth trend is showing you that the relationship is quadratic, the orange one, right? And then if you fit a linear model to this kind of relationship scatter plot, you will not get a very good fit. So going back to my linear relationship, you can also ask it to show correlation, because some of in the lab it is asking you to find strength of association, some measure. You can use that. It shows you what is the correlation between x and y. Squared of correlation r square 60%. It's pretty linear. 60% of the variation in y is being explained by x. This r squared, as you will see in guided notes, is same as the capital or uppercase r square that you get for the model fit when you fit a simple linear regression model. Remember, it's only true when it is simple linear. If you have multiple, then this won't be true. But the coefficient of determination r square is same as the uppercase r square for simple linear regression. It is representing the amount of variability in your y that your x is able to explain. 60% is pretty good. Then if you have a problem in the lab where you have to show residuals, you can click on residuals. And it will show you residuals. I wonder if it can. Residual standard deviation, standardized variable. No. So that's pretty much what it is showing here. Let's go to residual plot, and you can use this one if if someone is asking you to assess the model fit. You would go to the next tab where you can actually do residual plots. Some people do plots, uh, residual plots versus x, some do y hat. Both of them will give you the same message. uh, they should not have any trend over time. They should not have a funnel shape or any sort of shape, because the basic assumption for residuals is that they are independent, identically normally distributed with a constant variance. If there is some sort of pattern here, usually funnel shape, that is an indicator that the variance is not constant. And you can also fit a histogram so that you can check if they look normally distributed or not. Not that great of normality, I would say, right? You can overlay a normal curve and then check that. So if someone is asking you to test for the to verify the assumptions, model assumptions, this is where you would come for to residual plots. Okay, now let me take you to the other part of it. Then simple linear regression. you could fit a linear regression model. You could see fitted values and residual values here to here. Uh, so let's say if I take, I'm not going to take baseball. I'm going to take the housing price in Florida, let's say, right? So my X is the size of the house and Y is the price of the house. And I'm assuming some sort of linear relationship. And as you can see that there are outliers. These are way beyond the regular size and price range. And ideally, as a statistician, I would remove them when I'm fitting model. I would fit a model, separate model for this portion. And then I would think something else about this. And that would make my model fit better. You know, the measure of fit goodness of a model that you have fitted simple is R square, coefficient of determination that I was telling you a little bit earlier. This is 58% only, right? So you can, it ask to show its summary stats. You can ask it to show regression line because you, so that's your regression line in the lab. If they ask you for a regression, you can just ask it and it will show. So this is your beta naught hat 9161. This is your beta 1 hat 77. That's your regression line. You can actually use it to double check your answers when you're working on any problem in class, in your guided notes. You can remove points and see how it works better, and that's what I would do. But we are not into model fitting, like, you know, we are not in that. That's not the goal of this class. It's more about the mathematics and how it works, then a little bit understanding of where and how you're going to be applying these things, right? You can change title, subtitle, axis labels, and I would expect you to do that before you submit your lab so that it's neatly, because you can always copy this and download it, right? Now you would want to find predicted value. If you want to find for some specific value of x, let's say x equal to, what are the sizes here? So your x values are 22,000, let's say. So if the size of the house is 2,000 square feet, this is the predicted value of the house in Florida, right? You can also fit a smooth trend to see how big good. See, you can see up to this point, it is pretty linear. Something is happening here, curve. And that's why accordingly you will have different things. Now you can show residual plots on the plot. You can show standard errors and p-values, and that's what would give you. So this is your beta naught hat 9. This is your beta 1 hat. This is the standard error of beta naught hat, which is sigma square over sxx, something like that, remember? And this is the standard error of beta 1 hat, and this is the t-test that you manually do in your guided notes. So this is the answer, and that's the corresponding p-value. Again, you can find the p-value using this app also. There is a video in the certain for, like, you know, group a bunch of videos for this app on the course content area. You can also find confidence interval for mean response or for any specific individual response if they're asking you. So, and you can find the ANOVA table, which is also chapter 13, analysis of variance, and we also talk about it in the guided notes. So an analysis of variance approach is a different approach or another approach of coming to testing if you know, this regression is significant, if the effect of the variable x is significant or not. This is the amount of variability, that is sum of squares, that is the amount of variability that is being explained by the variable x or your regression model. This is the amount that is unexplained, and that is the total amount of variability. And then you compare those two variabilities and their ratio mathematically, that's a f follows f distribution. So you compare it with the standard f distribution with 1 and 98 degrees of freedom, and that gives you the p-value. And we talk about these things in the when we cover the course content. So you can do that. So for the lab, you can pick up a specific data, or if I have specified a particular data set, then you will use that data set. You can find more information about that data set by clicking here. You can change, you can upload the data from a file, or you can enter your own data too, right? So it's up to you what you're doing, and it also depends on what has been asked in the class. Sorry, I need to go back and make it from the textbook. And then here it is showing you the fitted and residual values, because sometimes the lab will ask you to have these values. So it's good to have this table. And again, you can verify your residual, fitted, and all these values in the problems that you're working on in guided notes. And you can always do a histogram and box plots of residual and superimpose it with normal curve. Something went wrong with my thing. I have five, six people using this internet in the house. Five, six, sorry, devices. So sometimes it gets slow. Okay, so I'll have to exit it, but I think we were done here. So that's pretty much it, and I'll see you guys in another video. Sorry, give me one more thing that I wanted before I leave. I wanted to show one more thing, that is multivariate relationship. This app doesn't have capacity to fit multiple regression model. I have posted an R lab to do that if you're interested in doing that. Uh, but it does have the capacity to construct interactive scatter plots to explore the relationship between two quantitative variables while accounting for a third qualitative variable. So that's what this multivariate relationship does. So let me see if I can get to that. Okay, snap, I can't. So we'll just stop here and I'll let you can just click on it and explore it. It is pretty self-explanatory. And I'll see you guys in another video.